Catus, Maximus here, just a little filler video about the Skil 2362. It's a little 7.2 volt cordless screwdriver, 500 RPM, a little, you know, spring-loaded type of clutch. Not great. I will say that even on the low setting, it's kind of a stiff clutch. Not a lot to say about this. Pretty lightweight. It is variable speed, but has an odd delay. The whole reason I even picked it up is I was noticing the charger, and actually I kind of like this little Skil ratchet that I had, and it turns out that the charger is the same on this ratchet as it is for this little drill, so that gives me a spare charger, because as far as tools, it seems that the chargers are what go out more quickly than, say, the tool themselves. Anyway, I won't be replacing my little IXO. I actually picked up an IXO 3. We know that because it has the F number is 401 instead of 400, and it has a white LED. Anyway, I like this as a little driver. Actually, I don't mind this pink one that I just picked up because it's less likely for somebody to walk off with a pink driver. Anyway, this is like the next version up. Not really great for drilling, simply because it's so slow, 500 RPM. But I will give Skil some credit. If we look, it actually has a surprisingly stiff spindle. Too bad it doesn't have any LEDs. So I figure we'll do a little drill test here and clean up some of the stuff out of the way. Get our block of wood in here. We'll just try a 3-inch deck screw, see how it wants to do. If it can, it will be at least decent as a driver if it can do a 3-inch deck screw into this kind of dry fur. Holy smokes, you gotta be joking me. I just charged this before the video. It does have this kind of neat thing, although it's interesting is the output of the directional light is based on the output from the trigger. So if you go slow, the light's dim, and if you go fast, the light's bright. When you go in reverse, same deal. When the battery's low, it glows red, and then that changes to green in the middle. But this is sad. It made that screw in about 1 inch. I mean, that's crazy. I mean, that's absolutely crazy. For a 7.2 volt driver, maybe the batteries are really that bad, but I doubt it, because this one's just as old. Alright, this little 3.6 volt driver just shamed this 7.2 volt driver. God, that's disappointing. Anyway, I'm going to get set up. We'll go and tear this thing down. Alright, knocking this thing apart with all its little tiny T9 screws. That's just unbelievable. Old batteries are not. An equivalent age 3.6 volt screwdriver should not outperform a 7.2 volt driver, even with crummy batteries. It's just, you know, that could potentially be an issue with the controller in it, just cutting out too early, but I doubt that. That's just ridiculous. Something that has 7.2 volts, it's only 500 RPM, ought to be able to at least drive a 3-inch deck screw into fur. I mean, that's for sure. Quite a few screws in here. There we go. Kind of hard to find little T9 bits. I had to really kind of dig, and I just decided to use this little T-handle instead. People ask, these are the Bond Huss ones. As far as like straight shank T-handles, the Bond Huss are really competitive, but I like them because they're consistent quality, they have a decent warranty, and they're reasonably priced for an American-made product, and they have really good sizing. They always have really nice tight fits. Certainly much better brands, but the only thing I don't like about Bond Huss is the sets are a little bit short, and like on this torque set, it only goes up to what, T40? And you can order T45s, T47s, T50s, but they don't have a set that actually includes it all. They don't have quote-unquote master sets, and that always puzzled me. Pull off the clamshell. there we go. Not too exciting. We'll see if there's any metal gears in the gearbox. There's our 2 batteries. Interestingly enough, they do have a temperature sensor in there, so if the batteries overheat while they're charging, it will cut itself off. And since the temperature sensors, also if they overheat while you're driving them, there we go, we can actually see some numbers there. Really lightly printed. Barely see it on the camera. 18650 OVT, 066. Kind of hard to tell, but I suspect these are really low output. Let's get all the guts out of here. A little bit wider angle. Get these wires out of here. Alright, there's all of our guts. Here's our little control board that also drives the little LEDs that are up here. We can see part of the LEDs are actually just wired right into the motor, so that's why the light was increasing and decreasing. If we look inside the motor, there is actually a fan in the motor, so these little vents, these little micro vents weren't actually entirely fake. Other than that, let's take a look at the specifications of the trigger here. 24 volts DC, 15 amps, so this trigger unit can certainly handle a lot more power than what this thing was delivering. We can see that the charger is actually a dumb charger. So here's the control board, and not only was it responsible for it cutting out so easily, but with the temperature sensor and all the circuitry, it means it's actually managing the charging of the batteries, and that battery charger was just putting out a basic voltage. Also find it interesting that they just had spade terminals on the batteries. Kind of an oddball aspect, but it does make it a little bit easier to recycle. They do have a recycle label, so being able just to open up and pull out the batteries is saying something. So technically I could replace the batteries, but I'm not going to on this little tool, that's for sure. There's just no reason for it. Anyway, let's finish tearing this thing totally down. We'll zoom in again a little bit here, just so I can show. It's always a trouble getting these little washers out, or the little retaining rings for these little chucks. It's always been kind of a hassle for me. I'm just trying to get some type of a screwdriver, or in this case a pick, right under there without stabbing yourself. A lot of times what you have to do is get 2 picks, kind of go sideways until you can get just enough grip under them. I mean, sometimes you can just, there's a little bit of a gap right on top where you can actually drive the pick in and get behind the back side of it, but that's not the case here. Alright, I figured out the trick with this one is to really drive in right under this little ring that retains the spring, and then drive under it, and I was just able to get it popped up. These little clips actually tend to be relatively the same size on a lot of different tools, so I actually tend to keep these little parts just because they might be useful in another situation. Only a single ball bearing holding the chuck together. This thing ought to just... Usually these just pop right out, but in this case it doesn't want to. We'll go and pop open the gearbox there. A couple little screws. We have this, oh, that's actually press fit on there. Little centered gear. 2 cross pins holding the gearbox together. Still to understand what's holding this collar on. Maybe the answer will be inside the unit. If I can keep this in frame, how about that? Wow, those pins are pretty tight. I'll have to tap them out. Got those pins out of there. Those are exceptionally tight. Those are definitely not going anywhere by themselves. And we can already see the first stage is indeed plastic gears. If I had a paper towel. That way I don't get everything super greasy. I tend to save these washers. They're handy in a variety of situations. And I can see down in there that there's actually a snap ring holding all this together. That's going to be interesting as far as how the clutch works. It's just putting pressure. This is the, oh, that's for the one-way clutch, so it is like a screwdriver. It has a sprag clutch in there. Here's part of the mechanism for the sprag clutch. Here's the interior piece, and then the little rollers. Sprag clutches have these little flats, and then when you try to back drive the spindle, it pushes those bearings out and causes it to lock up. I'll actually assemble that in a second here. The clutch is just putting a spring tension on these bumps, and so when you feel the clutch and cordless drills, what's happening is this is actually spinning and bumping up over a series of ball bearings that are inside some holes there. You can just see them shining right through there. Definitely a little bit greasy. Let me try to assemble this sprag clutch again. Bidirectional, and it actually has 6 rollers. So you have all these little rollers, or little pins, but they're essentially needle roller bearings. We have a bunch in there. And then the back side of this, these forks go right in between there, and that's essentially, so when this turns, it's pushing against the little bearings and allowing it to turn the spindle, but if you try to go the other way, it of course locks up. We do have metal gears on the second stage, but not on the first stage, and they are certainly very tiny. Let me see if I can't get this spindle out of here, although that snap ring, I don't think I'm going to actually be able to get down inside there to get that thing out of there. That's going to require some real specialty snap ring pliers. Well, I was magically able to get them out with these little snap ring pliers. Really odd snap ring because it's a tiny snap ring with really large holes in it. This should allow the spindle to finally get out of there. Oh, interesting. We got a bunch of tiny little ball bearings in there. Oh, that's cool. That's actually kind of innovative. All the ball bearings are riding right along there, so it actually had a needle or a ball thrust bearing. That kind of made it worth it. That's actually an interesting little design to have those bearings. They're sandwiched in here. This was the other race on the back of the spindle, and so that provided just a ball thrust bearing with a whole bunch of little balls in it. So, I mean, I have to give them credit for that. Too bad the thing is weaker than all get out. Bet we can get this other washer out of here. We can. That washer was just backed up by this sintered sleeve bearing, and this must be snapped on there. Never actually experienced something like that before. We've got this thing totally apart, and this clutch ring is still totally stuck on here. Not sure how they got that. I mean, it has to be some kind of clips or snaps. Anyway, that's the teardown of this little unit, the Skil 2362. A really cheesy electric screwdriver which had an interesting thrust bearing in it. Other than that, super weak and definitely would not recommend it. Anyway, I really appreciate everybody who's been watching and subscribing, and if you haven't subscribed, please do. Till next time, Catus Maximus out.